Ryder, what do you see on my screen?
The unit circle.
Hmm?
The unit circle.
Okay. So what do you think after you see this unit circle?
Um, I mean, I see all the different points and like
Okay.
the angles.
Okay. Do you know how you can use this?
Yeah, so you're trying to find like cosine or sine, um, and you're given like an angle. So you can
So
like,
yeah, how can you find like cosine 30 degree use this unit circle? Can you show me how you can calculate cosine 30 degree?
well, you look at
You can write on
the,
the screen. You can write on this both sides.
how do I write?
Yeah, you have a pen. You remember
Oh,
annotate. You can try to draw anything on my screen.
I mean, I just look at this 30 degrees and then look at the x coordinate because
Mhm.
cosine is matches with the x coordinate. And so cosine 30 degrees would be root 3 over 2.
Okay. So show me the detail. How you got that? You change your pen color to like a blue or yellow or red? Not yellow. Blue or red.
Yeah, so I look at 30 degrees.
Mm-hmm.
I see that the x coordinate is root 3 over 2, and I know that cosine relates with the x coordinate, so I know that cosine
Mm-hmm.
of 30 degrees is root 3 over 2.
Mm. Okay. So how you got this? How you got it? You think that's root 3 over 2? That's x coordinate. So how you can calculate cosine? Cosine equals what over what?
Um,
You just use x, then it means that's cosine. That's actually right because cosine that's x over r. Unit circle, what is the radius for unit circle?
the radius.
Yeah, what is the
Just
radius for
one,
this?
I guess.
Yes, 1. So then when you calculate cosine, that's x over r. So r equals 1, then x can already give you the cosine. So how can we calculate sine 30 degree?
Look at 30 degrees again, and
Mhm.
then you see that uh, the y coordinate is 1/2,
Hmm.
and that's our
Okay.
answer. Sine 30 degrees equals 1/2.
Okay. So then you can observe this plot one more time. Can you use this plot help you to prove sine x square plus cosine x square equals 1? Can you prove this? Here, x is an angle. Is any angle. Can you use this unit circle help you prove this?
Yeah.
Show me how to.
So if I plug in like 90,
Mm-hmm.
then I'll get sine square of 90 degrees
Mm-hmm.
plus cosine square of 90 degrees. Um,
So
the
say 90 is
sine
what?
sine 90 is 1,
Mm-hmm.
and then cosine square 90 is 0.
Mm-hmm.
And then, yeah, 1 plus 0 equals 1.
Okay. So you think by this way you can prove sin x squared plus cosine x squared equals 1?
Yeah.
Why do you think this way?
I mean, if x is like any angle, I'll just plug in like one of those easy angles and then I'll be able to prove it that way.
You know, this way that's called verify. So in
Yeah.
the logic, you know here here x should be any angle. Even
Yeah.
so you use 90-degree, you verify that's correct, right? So how can you think that this equation identity is true for any angle? Yeah, I agree. You use 90-degree, you verify that's correct. But how can you make sure this one's true for any angle? You just
Um,
use a special angle like 90, then you check that's correct. But how can you prove this one is true for any angle?
maybe just plug in some different angles.
Show me how you do that.
Let's say 45 degrees.
Okay, you plug in 45 degrees. Let's see what happened.
Sine of 45 degrees is root 2 over 2
Mm-hmm.
square.
Mm-hmm.
And then plus cosine square root or cosine square 45 degrees, which is
Mm-hmm.
root 2 over 2 square again.
Mm-hmm.
So you square those, gives you 2 over 4. That's 2 over 4.
Mm-hmm.
Add those together, you get 4 over 4 equals 1.
Mm-hmm. So here you verified 45-degree, this identity is true. But
Right.
how you can make sure this identity is true for any angle, right? Suppose like I ask you, say, man has two legs, right? Then you found, oh, my daddy has two legs. My brother has two legs. So then can you get the conclusion all men has legs, has two legs?
No,
Why?
because there's some people out there without legs.
Right, because the you only check the a few couples, a few examples, right? But then if you try to get a conclusion, that's conclusion claim all the men has two legs. So you need to find a way to prove all the men should have two legs. So here, this x is can be any angle. You need to find a way to prove for any angle this equation is true. How can you do that?
You just solve the equation.
How you can solve that equation?
Like solve for x.
Can you solve for x? Can you show me how you solve x? Do you think is other way? You know, the use general way, right? If this angle is, you don't know what is this angle, you can just use general expression to represent that saying cosine. Think what is a way you can do that. That's the reason you say I'm asking you observe this unit circle, think this more, find a way to prove this. So how you can represent like sin x in the general way? For any angle, sin x equals what? You can think, you can draw, suppose, okay, suppose this is that general angle. Suppose this one that general angle x. Then in this right triangle, how you can represent sin x?
Um, Opposite over um
Opposite over what?
hypotenuse.
Right. Then think, yeah, start from here. Think how you can do this. Say x equals, then do you need to give this opposite side variable? Use a letter to represent. Suppose this this one is like A, and this side is B. Then the hypotenuse like C, right? Then can you represent say x uses ABC? Say x equals what? A over C?
Square.
Say x equals what?
Opposite over hypotenuse, so A over C.
Yeah, then you write this one equals A over C. Yes. Then you can write cosine x equals what?
Oh.
You see, writer, do you think we generally write like sin x equals this? Is this can represent for any angle? Any angle, the sin of that angle will equals opposite over hypotenuse.
Yeah.
Is that true, right?
Yeah.
Okay, then can you write cosine x equals what? Also use ABC to represent. Okay, now can you continue calculate sin x squared plus cosine x squared equals what? Then can you prove now this one true? Can you simplify this left side? See what you get it? Do you think this one's true?
Yeah,
Why?
because it's every angle can like be in this form.
You know, in this, you need to prove this. See, we try to prove this, right? So the left side, if you simplify, you get the a square plus b square, then divided by c square, right? In this right triangle, a square plus b square equals what?
C squared.
So then you can simplify this one, a square plus b square, that's c square, then over c square. So therefore, this one equals what?
1.
1, right? So by
Yeah.
this way, you prove the sin x squared plus cosine x squared equals 1, right?
Yeah.
So here we did not use any special angle because sin x equals opposite over hypotenuse. This is a general. This is not for any special angle.
Yeah.
This one can be true for any angle. Now, can you try this? Can you prove, okay, 1 plus tangent, I use alpha this time, okay? X square, alpha square equals secant alpha square. Can you prove this? You still use this unit circle and also use this triangle what we draw here, help you to prove this. Can you prove this?
Um,
You can use this one. Suppose this one's still A, this one B, this one C. Okay, let's change this one to angle alpha. Can you prove this?
so tangent of alpha equals opposite over adjacent.
Yes.
So A over B. And then secant alpha is cosine flipped reciprocal. So cosine is um uh cosine is adjacent over hypotenuse, so it would be hypotenuse over adjacent, which is
Mhm.
C over B. So then plug that in to 1 plus A over B squared equals C over B squared. Um, and 1 plus A squared, B squared, B squared. 1 equals
No, rather you don't do this way. I'm
no.
thinking you just need, simplify left side. Say if the left side equals, check if the left side equals the right side. So if this one equal, we don't know, right? We are trying to prove this, but if this one true, we don't know. Now, if you simplify left side, then you get the right side. Then we prove that left side equals the right side. You can always write like this: left side equals the right side. Then you keep the simplify like that way. So you need now for this left side, then you simplify this. Simplify this. Say later after you simplify, you say if this one equals the right side. Then you start from here.
So you can turn 1 into b squared over b squared,
Yeah, continue.
And then we know a squared plus b squared equals c squared.
Mm-hmm.
So then this can equal c squared over b squared.
Okay, this is left
secant.
side. What is the right side?
Right side is secant square alpha, which equals c squared over b squared.
So now the both sides
They're equal.
equal, right? So by this way, you proved 1 plus tangent alpha squared equals secant alpha squared, right?
Yeah.
Okay, perfect. You can say this unit circle, this very, very powerful. Okay. When you have time, you need to do some practice. From this unit circle, you can find a lot of very beautiful trigonometry identities. Okay, so today we can stop here. See you. Thank you very much. Bye.